Saxon Algebra 1, Lesson 32. In this lesson, we study word problems. Question: what number is twice the sum of 3 and 4? Can you answer that? Well, the sum of 3 and 4 is 7, and twice that is 14. So the number is 14. Notice that we found the sum first and then multiplied it by 2. We did this: parentheses 3 plus 4 times 2. The parentheses indicate that we should find the sum first. We could also write 2 times parentheses 3 plus 4. If we say twice the sum of a number and 4, then we would have to use parentheses in translating this into an expression in algebra. We would write 2 parentheses n plus 4, where n is the number. Whenever a sum is to be multiplied by a quantity, then the expression for the sum must be enclosed in parentheses. On the other hand, the phrase "the sum of twice a number and 4" would be translated as 2n plus 4 without the parentheses. In this case, the number itself is being multiplied by 2 before the sum is found. Word problems in algebra are statements that describe equal quantities. These quantities are often phrases that can be translated and connected by an equals sign. Example 1. Twice the sum of a number and 4 is equal to 14. This can be translated into an algebraic equation. Twice the sum of the number and 4 is equal to 14. Example 2. The sum of twice a number and 4 is equal to 14 would be translated this way: the sum of twice the number and 4 is 2n plus 4, and is equal to 14 completes the equation. To solve a word problem in algebra, we first translate it into an equation and then solve that equation. We will use variables whose meaning is easy to remember. For example, we will use n to represent an unknown number, n for number. Here are some problems to solve. Problem 1. The sum of twice a number and 13 is 75. What is that number? Well, we will use the variable n for the number, and this translates as 2n plus 13. The sum of twice a number and 13 is equal to 75. Then we go through the steps to solve the equation. Add negative 13 to both sides, and that gives us 2n is 62. Divide both sides by 2, and we find the number is 31. It's important to check the result to see if it really makes sense. Let's see, if the number is 31, then twice that number is 62. And if we read the sentence, it says the sum of twice that number and 13. So the sum of twice that number and 13, 62 plus 13, is 75. Let's see, 62 and 13. Yes, 62 and 13 is 75. So it does check. It does make sense. Problem 2. Twice the sum of a number and 27 is equal to 206. Find the number. This problem says twice the sum, so we need to enclose the sum in parentheses. We have 2 parentheses n plus 27 is equal to 206. Now we need to solve this equation. Since there's parentheses in the equation and 2 out front of the parentheses, we need to distribute that 2 on the left. That gives us 2 times n plus 2 times 27 equals 206. And that simplifies to 2n plus 54 equals 206. Now we get n by itself. We subtract the 54 first. And that leaves us 2n is 152. And we divide by 2, getting n equals 76. So the number must be 76. But let's check it. The problem speaks of twice the sum of a number in 27. Let's see, the sum of 76 and 27, 76 and 27 is 103. And then it says twice that sum. So twice 103, and that gives us 206. And that's what it should be. So it does check. Problem 3. Find a number such that 13 less than twice the number is 137. Well, let's see. 13 less than twice the number. 13 less than means we subtract the 13, and we subtract it from twice the number. So we have 2n minus 13. And that is equal to 137. So there's our equation. We need to get n by itself, so we add 13 to both sides. And that gives us 2n is 150. Divide by 2, and we find n is 75. Let's check this. 13 less than twice the number. Let's see. Twice 75 is 150, and 13 less than 150 is 150 minus 13, which is 137, and that's what the problem said. Problem 4. Find a number such that if 5 times the number is decreased by 14, the result is twice the opposite of a number. Wow. That's a mouthful. Find a number such that if 5 times the number is decreased by 14, the result is twice the opposite of the number. Let's take this apart. 5 times the number is 5n, and we need to decrease that by 14, so we subtract 14. The result is what it's equal to, and it's equal to twice the opposite of the number. So there's our equation. 5n minus 14 equals 2 times the opposite of n. Let's simplify that right-hand side. That's the same as saying 5n minus 14 equals negative 2n. Now we need to get n by itself on one side. It's on both sides. Let's get rid of the negative 2n. We will add positive 2n to both sides of the equation. And that leaves us 7n minus 14 equals 0. Then we can add 14 to both sides. And that leaves us 7n equals 14. Divide by 7. And we're left with n equals 2. Let's check this. 5 times the number decreased by 14. 5 times 2 minus 14. That's 10 minus 14, or negative 4. And that result is supposed to be twice the opposite of the number, and it is. It is 2 times the opposite of 2. Problem 5. We get the same result if we multiply a number by 3 or if we multiply the number by 5 and then add 2. Find the number. Another long sentence here. Well, let's see. If we multiply the number by 3, that's 3n, we get the same result, so that means the result equals what we get if we multiply the number by 5 and then add 2. So that's equal to 5n plus 2. So there's our equation. 3n equals 5n plus 2. n is on both sides. Let's get rid of the 5n on the right. We'll add negative 5n to both sides. That gives us negative 2n equals 2. Divide by negative 2, and we have n is negative 1. Again, let's check the problem. If we multiply the number by 3, we should get the same result that we get when we multiply the number by 5 and then add 2. Let's see, 3 times negative 1 is negative 3, and 5 times negative 1 is negative 5, plus 2 does give us negative 3. So it does check. This is the end of Lesson 32. Your assignment, problem set 32 on pages 133 and 134 of your book.